Great, hi guys. We're just working out the recording thing. This lecture is going to be recorded, which is wonderful. I'd like to introduce Anthony Gabay, who's working with Mittel. He's going to talk about molecular mechanisms of psilocybin. Then we'll have a Q&A session afterwards. How long are you going to talk for?
Between 30 and 40 minutes, depending on how quick.
Okay. So we'll probably be done by about 7:15, and then we'll go off for something else.
Sounds good.
Great. Okay. Cheers.
So first of all, thank you very much for the invitation to talk. Can everybody hear me? Can anyone not hear me? Good. So today I'm going to present some data from our recently finished study using psilocybin. First of all, a bit of a caveat. I'm heavily dosed up on some cold medication. And the non-drowsy symbol on that seems to be a bit of a lie. So if I start to sink into delirium, just give me a kick. So this data we're going to be presenting today is very new. We only unblinded in our study 2 weeks ago. And so this is really a first pass at all the analyses. There's still a lot of analysis in progress. And so as a result, some of my interpretations are still in the process of fully formulating themselves. Also, this talk is going to be between 30 and 40 minutes long, so if you want to interject with questions as I go along, feel free to interrupt. So, to begin with, I will introduce you to psilocybin and what are some of its believed mechanisms that produce its effects. I will introduce you to MICA, which is the name we gave the study, so that will be the study design. And then, in turn, I will go through the subjective effects, the social cognition, and imaging data that we've analysed so far. So, psilocybin is the active ingredient of psychedelic mushrooms. When people ingest these mushrooms, there are a wide variety of effects which they feel. Highest among them is the profound alteration in their experience of the world around them, and vastly changed experience of their own consciousness. They experience things like time distortion, loss of their sense of self, vivid visual hallucinations. The way it works is psilocybin is broken down into psilocin, and psilocin is a potent agonist at serotonergic receptors. The main receptors which it acts at are the 1A and 2A receptors, but between the two compounds, it has quite a wide number of receptors that it hits. It also hits serotonergic 7 receptors, 2C receptors, a little bit of 3, we think. So to fully understand how these effects take place, there's been a lot of research recently into psychedelics. Particularly in London, we've been using psilocybin a lot with studies from Imperial. And research into psychedelics falls into 3 main categories. First of all, people are interested in the neural correlates of these altered states of consciousness that we are seeing when people ingest these psychedelics. People are also interested in how these compounds may be useful in psychiatry. And in particular, there's been a recent meta-analysis of old studies which looked at the potential to treat addictions like alcoholism. In Imperial recently, I think it's ongoing actually, we have a study which is looking at psilocybin-assisted psychotherapy for treatment-resistant depression. It's finished.
Yeah, the paper comes out next week.
Ah, excellent. And finally, we have mechanistic studies, which are looking at more the molecular mechanisms of the subjective effects of the psychedelics. And the data which I'm going to present today comes from these types of studies. So we are interested in the molecular mechanisms which underlie the psychedelic effects. In reality, there's a lot of crossover between these 3 types of studies, and they all inform each other. So, in order to understand the molecular mechanisms, we first of all need to understand a little bit about how we think psilocybin has its effects at a receptor level. So, I mentioned that psilocybin is a serotonergic agonist. Serotonin receptors are G-protein coupled receptors, which basically means that intracellularly they are bound to what are called G proteins. When there is no ligand attached to the receptor, these proteins are in an inactive form, and then when a ligand binds the receptor, there's a conformational change in this receptor which allow these proteins to be able to initiate intracellular responses. There are a number of different types of these G proteins. I'm just going to mention two of them because they are the relevant ones, GQ11 and GIO. And it seems that when psilocybin hits the 2A receptors, both of these subtypes seem to be involved in the response. However, when serotonin, which is the endogenous serotonergic compound, and other non-hallucinogenic drugs hit the 2A receptor, this does not seem to be activated. So the question is, what is it which is special about psilocybin, which involves both of these subtypes of G proteins? It seems to be that when psilocybin acts on the 2A receptor, there seems to be this dimerization with the metabotropic glucose receptor 2. And this is all based on rodent work, by the way. And this seems to be important in enabling this subtype of G proteins to be activated. And more recent rodent work has also shown that it is a particular group of tyrosine kinases which are downstream mechanisms. So this is basically a protein which gets initiated by this, and it seems to be this pathway which seems to be important for the psychedelic effect, because in rodents, when you knock out that pathway, you see reduction in the psychedelic effects on rodents. Now you may ask how you know if a rodent is tripping. Basically, they shake their head a lot and switch their tail. And knocking out this protein pathway in rodents reduces both of those standard behaviours. So the purpose of MICA, the study which we have just finished, is that we got hold of, from AstraZeneca, a drug which blocks tyrosine kinase. And so we have attempted to see if we can attenuate or reduce at all the effects of psilocybin in the brain, or its subjective effects in humans, by blocking this particular pathway. So you can think of it as a proof of concept study, that the same thing is going on in humans as is going on in rodents. So this was a double-blind, placebo-controlled crossover study. Participants came in on 3 occasions. First of all, it was a screening where we checked their mental health and their physical health to make sure we weren't going to put them in any danger. Secondly, they came in for 2 full study days. On both study days, they received the psilocybin intravenously as an infusion. And on one day, they received saracatinib, which is the name of this blocker drug, and the other day, they received a placebo. So it's a crossover design. So in the first session, half the people received placebo and half of them received saracatinib, and then crossed over for the second session. We recruited 23 people, 3 of which did not complete, and so our complete data set is 20 people, an average age of 26 years. And one of our inclusion criteria is that everyone had to have had experience with a hallucinogenic drug previously, and none of those experiences could have been negative. So we were excluding people who had previously had bad trips. We're happy to say that from neither the saracatinib nor the psilocybin did anyone have any serious adverse events at all. In fact, most people reported very positive events.
Do you have any demographic data on how many experiences of kinds of drugs these people have?
At the moment, we don't. But I was planning on following up to email them and ask them more detailed questions about this.
So you use saracatinib for anything else? It sounds familiar.
Yes, so saracatinib is it was originally developed in cancer research, and it has been developed by AstraZeneca to see if they can help.
It's not licensed for anything.
It's not licensed.
You shouldn't have used it. You shouldn't have used it. Then you're...
No. It's the inib bit at the end. Or the anib bit.
The anib. Yeah, I think it is inib, actually. I think I spelled it wrong. Yeah.
Just read it's incomplete.
Yes. Why?
Yeah.
So 2 of them were because they never actually got around to the scanning session at all beforehand. So one person had a panic attack before going into the scanner, and we hadn't given him any drugs at all because he was on placebo that day. Another person had... it's Toby, in fact. Oops, I've just broken confidentiality. Toby in a different room, in a different place. So this mythical person, some of his ECG readings were not within our range. And so they were fine at screening, but when on the day, one of his ECG readings was out of range, and so we couldn't continue with the study. And the third person withdrew from the study because, he failed a drugs test in the morning, and so we couldn't go through with our second session. And by the time he was able to pass that drugs test, we had already completed the study, so we couldn't include him. So on each day ran exactly the same. In the morning, they received either saracatinib 125 milligrams, which is a very low dose compared to other studies which have used this in cancer research. In fact, I think it's the lowest dose that's ever been used in research. Or they received a placebo. Then they had the scan about 4 hours later. So saracatinib has a very long period of time to reach peak levels in the bloodstream, so we left for 4 to 5 hours between administering that drug and putting them in the scanner. And then afterwards, we asked them about their subjective effects and did some social cognition tasks with them. The scanning session itself looked like this. So we have some structural scans, we have ASL, arterial spin labeling. The moving dots is a visual processing task. The breath hold is to look at non-neuronal changes in the bulb signal. And then the pharmacological MRI, during which they received a psilocybin infusion. And then we basically repeated those afterwards with the addition of a reaction time task. Today, I'm going to be concentrating on the subjective effects and social cognition tasks and the pharmacological MRI. So, subjective effects. In order to, as soon as people came out of the scanner, we gave them a questionnaire called the psychedelic questionnaire, which we took from the group from Imperial. It's the questionnaire that they used in their 2012 PNAS paper. It's got a number of subscales, or a number of items on it, 23 in total. The data I'm presenting, so like I said, this is all very new. We only got unblinded 2 weeks ago. So the data I'm presenting is just a top-line question of how intense did you find the drug experience. So this is from the Imperial paper. These are the top 10 rated items that they found, and you can see massive effects of placebo versus psilocybin. And so what we're predicting is that we'd see on the placebo day, when they're only receiving psilocybin, we'd see these big effects, and then a reduction in those effects when we give them saracatinib. So you can see the sort of subjective effects they're feeling here. Things like, I saw geometric patterns, my imagination was extremely vivid, and like the sounds influenced things I saw. So you can see this real blurring of the boundaries between senses that people have. So, this is the question. How intense were the drug effects when at their peak, ranging from no effect to extremely intense? Psilocybin by itself showed a high effect of the drug, which is as you would expect. And then psilocybin plus saracatinib shows, so this is Cohen's D, so that's a moderate effect size. So a moderate but statistically significant reduction in the subjective effects of psilocybin on saracatinib compared to not on saracatinib. And so this is our first hint that perhaps saracatinib is doing something. So that was reassuring. So I'm now going to talk about social cognition, but I need to spend a little bit of time talking about the task that we used, because I imagine many people don't know it very well. But social cognition is basically a collection of mechanisms which we all employ to navigate our complex social world. It includes things like being able to recognise people's emotions, being able to infer what other people are thinking, and perhaps being able to feel what other people are feeling. So it's long been believed that the serotonergic system has a lot to do in social cognition. Most prominently amongst that is the fact that SSRIs are the biggest treatment for depression, or the most frequently used treatment for depression. The area of social cognition which I'm particularly interested in and which my PhD focuses on is social decision making. So social decision-making is an area of social cognition which has recently received a lot of attention. So in the last 10 to 15 years, there's been a vast increase in the number of studies, neuroimaging studies, which have been looking at social cognition. And it relies on tasks which model the processes behind abstract concepts such as cooperation, trust, and fairness. And so we're really interested in what the processes are behind these concepts. There's been a number of drug studies looking at these things, and social decision-making, like I say, has increased in the number of studies looking at it. Molly Crockett is quite prominent in this field, and there's also a study a couple of years ago published by the UCL group looking at MDMA's effect on social decision-making. And all of these studies point towards a strong serotonergic effect in social decision-making. The particular task that I've been looking at is called the Ultimatum game. So, the Ultimatum game is a two-player game. You have a proposer and a responder. The experimenters give the proposer a whole bunch of money, and they are asked to split it with the responder. So they have to offer something, but they can't offer it all. Typically, people are given the choice to have 10% increments of the total sum. So if the total amount is £20, then they can give 2, 4, 6, 8, 10, all the way up to £18 to the responder. All the responder has to do is decide whether or not he wants to accept that offer. So if he accepts the offer, the money gets split. And so if £2 out of 20 was offered, then the responder keeps £2 and the proposer keeps the remaining 18. And if the responder rejects it, then nobody gets any money at all for that round. And so the experimenter takes it away. So typically, these games are played as single shot, meaning each time these two people meet is the only time they'll interact with each other. So according to rational choice theory, the responder should accept any amount of money because it's more money than they had before. And they're never going to meet this person again, and so why not just accept the money? But what we find time and again since 1982, when this game was first introduced into behavioural economics, is that when the offer is perceived as unfair, and this tends to be 10 to 20% of the total sum, people reject that money. When it's fair, so 50% of the total sum, people are happy to accept the offer, and 30% is somewhere in between, and there's quite a lot of variance in how people respond to 30% offers. And so just to make this clear, what this is saying is that even though these people are never going to meet again, this person is willing to reject money if he thinks that it's an unfair offer. Now, there are many reasons why people think this happens. Most prominent among them is this idea of altruistic punishment, so where people are having a costly punishment for the benefit of society. Now, I know that sounds very abstract, but there have been many published studies, particularly in computational evolutionary theory, showing that this kind of pro-social behaviour is more likely to evolve than purely selfish behaviour in a society. Now, obviously, there's a wide range of how people respond to this. So some people do accept all the offers, some people reject it a lot, and some people are somewhere in between. But the theory is that, in fact, there's a paper published just yesterday showing that one of these behaviours can't seem to evolve without the other. So, that is the Ultimatum game. So the other important thing to think about is you need to see if it is indeed a social effect or just a monetary reward effect. And so most studies look at a social condition. MS here stands for myself, and so the offer's being made to themselves and they have to respond, and both people are affected by the outcome. And RNG is random number generator. And so the participant is told, in this case, that a computer is randomly choosing an amount of money to offer, and obviously you don't give the computer any money. So we had a fair split of the money, 50-50. We had unfair splits of the money, which were between 10 and 20%, and we had hyper-fair splits of the money, which are between 80 and 90% of the total sum being offered to our participants. So with these tasks, basically, you're leading your participants to believe that they're receiving offers from real people. And there are a vast number of stories which are given to them across the literature to make them believe that these offers are coming from real people, because in fact they're normally made up by the researchers because you want to see a whole range of offers from 10% all the way up to 80%. And in the real world, most people will offer between 40 and 50% of the money. And so the first thing we did was validated this task to make sure that our version of the task would produce similar to results to that in the literature. On the right is a graph taken from a meta-analysis we published a couple of years ago. And this shows that with increasing offer, you see a reduction in rejection rates. These are 11 studies here taken from the meta-analysis. And on the left is the results of our test-retest reliability study. So our test-retest reliability study had people come in twice, at least 1 week apart, and play the game exactly the same to see the consistency of their types of responses. And here in blue, so this is taken from their first session, and here in blue you can see the social condition where on average people rejected 80% of unfair offers, or 10% offers here, and then that reduces in the same way as these all reduce here. And secondly, in red we have this non-social control condition, and it's worth pointing out here that we actually saw a lot more rejections in our non-social control than we typically see in the literature. Normally that's around about between 20 and 30%. We have actually altered our version of the task since the psilocybin study, which is seeing much lower non-social control rejections. But the thing to notice here is, first of all, that we are seeing a difference. There's still a statistical difference between these two conditions. This is Cliff's D, which is a non-parametric equivalent of Cohen's D. So this is a moderate effect, and it's statistically significant. And also, just to drive the point home, people reject unfair offers much more than they do fair offers. So this is a very large effect, and very statistically significant. So we're happy that this is going to investigate what we're after. No, we're not. First of all, this is our test-retest reliability. So when you have a within-subject design, it's important that you know that the task is reliable across sessions and that people are going to respond in the same way. So here we have the percentage change in rejection rates between sessions in our retest study. And so with the fair and hyperfair conditions, you can see that nobody except for this person here, who probably pressed a button by accident, changed their responses. And so they basically accepted every single fair or hyperfair offer in both conditions. And then in the unfair condition, you see a little bit more variation. So there's a very good repeatability in the social condition, and a slightly less good repeatability, but still acceptable, in the computer condition. And what you can see here in the green triangles is the computer condition, and most people actually reduce the number of times they were rejecting unfair offers in the second session. And they even said to me afterwards that it's because they had time to think about it and they realised that there was no point rejecting a computer because it wasn't going to help anything. But still, like I say, it's within the accepted range of reliability. So, to our psilocybin study, on the left we have our screening data. This is when there were no drugs involved at all. In the middle we have our psilocybin data, and on the right, psilocybin plus saracatinib. What I want you to take from here, mostly, is the fact that between unfair, fair and hyperfair, there were big changes. And so for the rest of this slide, I'm only going to talk about the unfair condition, because that's what we're interested in. In green, we have a box plot showing the rejection rates of unfair offers in the screening session. And in orange here, the same, but when people are on only psilocybin. And what you're seeing is a small but statistically significant effect of psilocybin. So when people are on psilocybin, they are more willing to accept what they perceive to be unfair offers. And then on the sessions where they have saracatinib, again, a statistically significant small reversal of this effect. And so just to drive that home, when people are on no drugs at all, they reject a lot of offers, like we see in the literature. Psilocybin reduces that rejection rate, and then saracatinib blocks that reduction. So that's two pieces of evidence that we've got that saracatinib is actually doing something. We've got the subjective effects, and we've got this ultimatum game data. There was also a main effective target, so people are rejecting unfair offers to social people more than computers. So now I'm going to change tact and start talking about our MRI data. So we use a pharmacological MRI approach. Pharmacological MRI was first published in 1997, where people were looking at cocaine. And the benefit of pharmacological MRI is that you're looking to see if you can see any brain regions which alter with the drug effects. And so people tend to use some sort of template. In this study, they had behavioural ratings of how much people felt the rush or were craving cocaine after an infusion. So the first 5 minutes of the scan, people were there with no drug. Then they were infused. And then you had these behavioural ratings of these different outcome measures. And then you can use that as an input function to your data analysis to find regions of the brain which co-vary with those data points. And in this study, they found that they could discriminate between areas of the brain which co-varied with the rush of cocaine, which were different from those which co-varied with the rush or with the craving effects. And so pharmacological MRI, since this first study, has been used relatively often in our group in the imaging, in the CNS. We use it quite a lot. We've published a couple of papers on ketamine, for example. I say we, I haven't, so they have. So to remind you what we did, this is our 15-minute pH MRI scan. 5 minutes into this scan, we infused psilocybin, 2 milligrams of psilocybin, for 2 minutes. Okay? This is the same protocol as was used in the Imperial 2012 paper, except for their infusion lasted 1 minute. In order to get our template, our input function, to see which brain regions were varying with the drug effects, we turned to a 2010 paper where participants were infused with 2 milligrams of psilocybin, and then for the next 20 minutes were asked to rate their subjective ratings. And so from this, we produce an input function. This is a gamma variant. And you can see it basically models the subjective effects up to that point. So when creating the input function, everything is 0 leading up to the infusion time, and then we have that curve. In the 2012 paper, psilocybin paper, they found 3 areas of particular interest which decreased in cerebral blood flow with psilocybin. These areas were the thalamus, the anterior cingulate, and the posterior cingulate. And so we had an a priori hypothesis that the same would happen with us. And so we used these regions as our regions of interest for our pharmacological MRI. And we are hypothesizing that on the psilocybin day, we will see these decreases in bold activity. And on our sarocatinib day, these decreases will be reduced. So, these are the average time course of our regions of interest. These are bold values. You can see pretty much where the infusion took place. And this is just on the psilocybin alone day. And so for each region of interest, we had these dramatic reductions in bold signal. And these are very, very strongly significant effects of the psilocybin. And then on the sarocatinib day, in red, you can see that there's an awful lot of overlap. Now, these p-values here are comparing the fit of each session to the gamma variant. And so in the thalamus here, you can see there is a significant difference between the sarocatinib session and the psilocybin session. Here, it's edging towards significance, and in the PCC, you're not seeing much at all. And so this is really interesting because we have our subjective data, we have our social cognition data, all saying that there's quite remarkable effects. I mean, subtle, but definitely there are effects. And yet here, we're only seeing tantalizing evidence that something might be going on. Now, like I mentioned, these are our first MRI analyses of it, and so we've got a lot more data to churn our way through, and where we might be able to investigate some of the more subtle effects. But so far, this is what we have. So, analyses and progress. We still have our ASM data to look at. The reason I haven't presented any of this is because this is only on a subset of the data, and I want to use all the data before presenting it properly. But this is basically just the main effect of psilocybin, where we're seeing massive decreases in cerebral blood flow, pretty much all over the brain. We haven't fully looked at the sarcocasinib effect yet. We also have a moving dots task. This is a visual processing task, which Sam is going to be looking at for us. We have a breath hold task, which is going to look at non-neuronal components, changes in the Volt signal. And we also want to look at some of the connectivity measures. Particularly, I'm interested in seeing if there's any differences in connectivity in areas which we've highlighted as being important in the Ultimatum game in our meta-analysis. And also, we took blood samples throughout the day, and so it's going to be really interesting to see how the levels of both sarcocasinib and psilocybin co-vary with all of our different measures. So, to conclude, first of all, we've seen clear effects of psilocybin on the subjective effects, social cognition, and fMRI data, PHMRI data. We've seen evidence that sarcocasinib attenuates subjective effects and Ultimatum game rejection rates, or changes in. And we've tantalising evidence that something's going on in the imaging data. So, that just leaves me to thank a bunch of people, my funders and our collaborators at Imperial. Thank you very much.
So I want to ask, you used a low dose of sarcocasinib.
Yes.
Is there any particular reason?
So sarcocasinib has got a side effect profile, which includes dizziness, vomiting, diarrhea, and other fun things like that, and quite heavy nausea. And so we wanted to use a low dose to try and avoid as much of those as possible.
So could they tell when they were on it?
So at the end of each session, we asked them to say which drug they thought they had, placebo or sarcocasinib, and also rate their confidence in their answer. And so just taking into account the second session's answers to that, because obviously the first session they've got nothing to compare it to, almost all of them were heavily confident that they knew exactly when they were on sarcocasinib. And they were correct with approximately 47% of the time. But they were very, very clear that there was one session which was much, much less intense than the other session. And it had nothing to do, because I've done an analysis on it, it had nothing to do with the order in which they took the sarcocasinib, and it wasn't always that they were saying the second time was less intense or the first time was less intense. So even though they felt like they definitely know when it was on it, they were mostly wrong.
They didn't tell.
No.
Various questions. Firstly, with the sarcocasinib, what does the animal in vitro data suggest about how much you're blocking SLC with those kind of doses of 125 milligrams? Is it partially blocking, or?
So the animal data for the sarcocasinib isn't the same as the animal data for the SERT kinase.
Right.
So they haven't tried any psychedelic studies with this in rodents.
But I mean, just in general, do you know that does 125 milligrams totally disable the enzyme, or is it at 50%?
That's a good question. Miss, or do you know the answer?
No.
There's one animal study. I mean, there's safety studies, of course.
Yeah.
There's one animal study, which is that paper that you very much not that I'm passing it up. And there's two human studies, of which this is one, and the other one's an Alzheimer's disease. So we do know from the animal data and the Alzheimer's study that you can pick it up in the CSF, but we know nothing about the level at which it has an effect. So we had to choose the dose based on the safety. So yeah, it was a risk. In the AD study, they're titrating the dose up to start at 100 and they'll go up to 250, I think. But we didn't have enough data when we started to use the high dose.
So this is being investigated in Alzheimer's as well? Maybe that's where I've heard it. Is that?
It's in the States.
Right.
It's like it's being run. I think
Mostly
would have been better.
because we were using the 2012 paper as our guide. We basically used, and that's what was used in that paper. We wanted to be able to replicate the same kind of, yeah.
It's not taken, I think you're right.
Yeah.
Which is a mistake in the 2012 paper. I would have positioned done that.
Yeah.
And then finally, with the scanning, is that the resting state scans, are they open eyes or closed eyes?
Open eyes. Do you have insights into that?
No, just Chris, you probably come on this better, but like, because in the LSD imaging study, we didn't see these kind of like just bold decreases as strongly. That's right, isn't it? So compared to psilocybin, and it's much more about the functional connectivity. And there was some discussion about whether eyes open or eyes closed could be affecting some of those measures.
And what did you guys have?
I can't remember which way around it was now. Can you?
Yeah, but it's also not like strictly bold, it's just kind of feeling measures. They didn't want like strict bold fMRI measures. So there may be a difference in the analysis as well.
But did we not? I thought we didn't see any. I thought they did look at strict bold in LSD. Didn't see any decreases in the same way they did psilocybin.
They didn't strict bold, just like ASL and connectivity. Outside connectivity.
ASL show again.
No, increases.
Increases.
Yeah.
Increases in visual cortex.
Can you tell me on neuroimages what you're talking about?
So basically these decreases that you've shown and that was shown in the 2012 paper in psilocybin, and the original story that people want to tell us that there are only decreases, and these decreases are really important, but that is kind of slightly less the case, I think, now, and our team is more interested in the functional connectivity as a marker of effects rather than these kind of crude bold decreases. And some of those are also motion driven, like there's a high, especially between the what's your
What do you mean?
so what's your ROI? Is that in that?
So we've taken our ROIs from the Harvard Oxford probabilistic atlas, and so the thalamus, the PCC, and the ACC. So the ACC actually encompasses the entirety of it, and for me, it's not quite selective enough. I think it goes too much. It goes way too posterior, but we are still seeing the decreases.
Motion-driven stuff, James, like some of the effects in that original psilocybin study, because of the comparing front and back seeds, like there's a high, with all motion, you get obviously on that kind of axis, you get a much bigger effect.
Yeah. So these are corrected for motion,
Yeah.
and also scrubbed for large spikes,
Right.
and also we had a linear drift term in there as well.
Which I don't think any of the 2012 psilocybin stuff was.
Really? Okay.
I think that's more
Interesting.
prior to that kind of thing.
Yeah. Was.
Thanks, Anthony. That is an ROI analysis. But what happens at the oxalate ordinary level getting function?
So I'm not fully confident in these results, which is why one of the reasons I haven't presented them, because we've had issues with the analysis. But what we are seeing seems to show decreases in activity along the entirety of the cingulate. No increases at all. Again, this is the same type of analysis following the gamma variant. So decreases posterior, the entire cingulate, and also the posterior region bleeds out into the precuneus.
Slightly related. The actual shape of the gamma variant, we talked about it, I think, on the previous slide. You take it from another study.
Yep.
You do fit to that graph to get this one.
So,
or what influenced your
this
of choice?
This curve of subjective effects is quite common in drug infusion studies, and I used a Kessman paper, one of Order's papers, which showed subjective effects very similar to this, and used the same equation to get this gamma variant, basically. We could have just done the points exactly, but we wanted to perhaps capture... Actually, I don't know why, but we went for the gamma variant instead of doing these exactly.
My question was just if you change that blue curve, what happens to the results? Because that's sort of a systematic of your method that you assume some shape and
exactly
and measure a difference. So
and so this
it's worth tweaking it a bit to see.
Exactly. Well, we're tweaking it a lot, I think. So there's a whole load of analyses I still want to do, and that is one of them is not use the gamma variant, because you never know, the subjective effects may not be, also the changes in brain activity may not be as obvious as just following the subjective effects. And like you guys are saying, it could be connectivity. So yeah, there's a lot more analysis to do in this data for sure.
Do you?
Sorry, I was just wondering why the rate of infusion, is it 5-fold stronger than the original psilocybin study? Is it instead of 1 minute, 5 minutes?
No, so the infusion came in after 5 minutes and it was 2 minutes.
Oh, okay.
Yeah, so the infusion time is 2 minutes and it started 5 minutes into the scan.
Okay, well the original is also 2 minutes, right?
The original was 1 minute.
1 minute, okay.
Yeah.
And why did you decide to, because it's less, right? So
Yeah. Again, I wasn't involved in that decision, so...
We spoke to Robin at length, and we thought that they were infusing by hand, and we were infusing using a pump as well, so it's more consistent. And what we didn't want to do, some people in that original study had quite a hit, quite a big experience, and we were worried particularly about movement in the scanner, and changes in heart rate and physiological parameters. So we thought if we can just spread it, because we've got the pump against by hand, we can spread the infusion out a little bit and just soften the blow. And so we thought we'd put it in for 2 minutes. It wasn't empirically based, it was just for that reason, to try and make the experience more tolerable.
yeah.
Especially because we wanted to have everyone come twice. Actually, the original design was 3 times, and that's where the 2 minutes was really important. But we couldn't get funding to give psilocybin 3 times, so the funding would feel uncomfortable.
Really?
Yeah.
What was the funding body?
NRC.
Right.
But yeah, they basically said they don't like the idea of giving it 3 times, they'd rather give it 2. There was no reason, just that they didn't like it. Anyway, so that was the reason.
But of course, that rate of infusion could be causing differences in the subjective effects of the feeling.
Exactly.
We've tried to mitigate that a little bit by, so my gamma variant function fits in, so here, so this -1 here is the beginning of the infusion for that study. And so my gamma variant function starts at 1 minute past the infusion time. If that makes sense. So,
This is one method of analysis that allows you to keep all the temporal information in the data. There's no bidding of the data, for example. The reality is that actually it's a regression, and it's very robust to changes in the peak by 20 to 30 seconds, and the shape as well. It's very robust to that. So the shapes could be quite flat, or it could come down a bit quicker. You're still going to get a very strong fit in this model. So it works very well. But if you look at the data, we extract the data, of course, from MRIs, the effects, huge. This is beyond what you'd see in terms of, if it lights off to lights on in the visual cortex. It's a huge effect. So even if we tweaked that model, it result wouldn't change. So we did a lot of that in our earlier studies with lots of variances, grid searches of parameters, and you really have to change things quite a lot for it to make a difference in the results, especially for effects like this. But Anthony's right. I think when we go to the whole brain analysis, we need to be more nuanced in our approach.
How does subjective effects of psilocybin differ from those of LSD?
So generally, the LSD effects last a lot longer. They're a lot more intense. Actually, Luke's probably the best person to ask about this question because he's done studies on both of them.
I would
But
say that it's sort of very dosage dependent. So that's just the biggest factor. I think duration and time course is the biggest difference in LSD. Because the dose higher, they get pretty similar.
Yeah.
so recreationally, I think people describe psilocybin as being like a much calmer drug, easier to control. However, with these, when we're infusing them, they're having very, very strong effects. Sort of eyes open, geometric patterns, which a lot of the time, recreationally, I don't think you'll find under psilocybin necessarily.
The biggest pharmacological difference is that LSD is a DT agent, whereas psilocybin isn't. And so whether or not that makes a big difference, I don't know. But
Other questions?
I have a mechanistic question. I'm not a neuroimager, but is this dimerization between, not dimerization, but the combination of receptors of metabotropic glutamate and the 5-HT2A, is that psychedelic dependent, or does that happen anyway? I understood it happens anyway.
It happens anyway.
Yeah.
So I think it's the Moreno paper?
Yeah, exactly. But if you, because with rodents, when they bred knockout rodents for the mGlu2 receptor, you abolish the effect, don't you, completely?
Yes.
Yeah.
Exactly. So it seems to be.
So it's not a, if you like.
It's not a psychedelic specific
Two-A
effect.
is necessary but not sufficient.
Yeah. Exactly.
And ibogaine hits the mGlu2.
Is it?
It's part of its profile. Ketamine, well, it will affect the mGlu2, but indirectly.
Yeah.
Mark all that. You know all about mGlu2. But, I mean, ketamine would hit the mGlu2, but indirectly, wouldn't it? I don't think it has a direct effect.
I had an interesting conversation with Frank Bolenwine a few years ago where he said that their lab developed some mGlu2 antagonists which they'd given to people, and they suggested they produced these kind of like dream-like effects. They weren't like classic psychedelic, but definitely an altered state or something. Antagonists. So it's the other way around for the mGlu2. It's like I think it has to be antagonised and the probably has to be agonised for the diamond to produce those kind of natural effects, if I remember correctly.
So my understanding of it is that the dimerization actually activates the mGlu2 in terms of ligands for it are unable to bind to it because it's dimerized.
Right, so that's
So,
makes
but
sense.
it's the same
Like
thing,
an
but yeah,
antagonist,
yeah.
basically.
And then the downstream effects of these two, I don't know how much you know about that. As far as I understand it, it results in a modulation of sort of rectifying the currents through the membrane.
Yeah, so we spoke about this on email, and I don't know I don't know any more than I did then. Basically, it's really difficult. I just don't think the studies are out there, basically. So we don't really know what the effects downstream of this are.
Those pathways are very complicated as
Yeah.
well. There's 2 or 3 different things that we know about, and there's probably 3 or 4 more that are yet to be discovered, and
Yeah.
a lot of them join up to...
Exactly. So I think the further away you get from the origin of it, the more options there are of things to
Exactly,
happen.
yeah. There's another one, there's like alpha 13, 12 or something, which kind of links back through like a kind of long chain into the... There's all the papers that studies before look at like these downstream products like IP and AA accumulation in the cell, and those kind of all tie into each other, and it's very, very complicated.
But it's a fast effect, isn't it? I mean, you give the drug and bang, it's working. So,
I mean, I guess it's fast, but it's not as fast as like, I mean, to the point about G protein coupled receptors, they have a slower modulatory effect than the direct.
also because of your eyes, depends on the G protein.
I mean, it's slower and it's broader though, right? It has like a bigger effect over the inside and outside the cell to accumulate on the downstream.
If neurology researchers, it's fast.
Yeah, exactly. Yeah.
I mean, it's seconds. I mean,
Yeah, but it's not milliseconds. Right? Yeah.
seconds, exactly. It's not NMDA receptor fast, of course.
No.
And of course, the big problem with all this is that like there is no clear relationship between psychedelic drugs and the relationship between these two. There are lots of people who have hypothesised, oh, maybe a stronger psychedelic effect on these pathways and all, but it's just not true.
Sorry, say again?
So there's lots of hypotheses that like the more potent the psychedelic drug is, it might affect one of these pathways more or less,
Right.
but it doesn't hold up across a broad category of psychedelics. So it's,
But it does hold up that there might be a differential involvement in pathways.
Yeah. Well,
Yeah,
that's
in
really-
rodents.
but we don't know
I
what.
mean, this is the first human study that's trying to test this hypothesis.
Well, I'm going to ask you, is there anyone else looking at this? With the IOP?
IOP? No, I hope we know about that.
Yeah. But I don't know why maybe with the cellular level, actually.
No, there isn't.
Anyone else that you know?
No.
There's all the people, there's the Nichols team that did all the cellular
Yeah.
work like
Yeah.
in vitro stuff.
Yeah. Anyone else got any more questions? Great. Thank you, Anthony.
Thank you very much.